All right, welcome everybody. Welcome to the VCG platform sprint review. We are here with 4+1 teams, and we are planning this session about less than an hour, let's just say. Or of course, it depends on your question, which I would like to encourage you to raise your questions in the live chat, in the comments. So we can answer at the very end of this session where we have a Q&A session. So please enjoy this review. My name is Balázs Bézi. I'm supporting the platform teams. And today we are going to start with the Tenderdash team.
Hi, my name is Łukasz and I'm a member of the Tenderdash team. So right now we are moving into the goal of implementing same block execution mode in Tenderdash. Basically what we planned in previous sprint was to do some research on this topic, which was done. We discussed the outcome and we are getting into implementation right now. And the same block execution mode, execution topic is on the critical path. So we will focus on this. And we also worked on the vote extension documentation. And that documentation is in review right now. And also we implemented validator key verification, which is also in review. However, as we see the same block execution as the priority, it will move forward slowly for now. So let's say it's on hold. And next sprint and next few sprints, we will spend on implementation of same block execution mode, which is a big change to the consensus project algorithm and to the Tenderdash itself. This change spans over multiple elements of the source code and also has big impact on the drive architecture and drive operations. So this is quite a huge project that we need to work on. I think that's it on Tenderdash.
All right, thank you very much. Grovedb, Wisdom.
Hey guys, this is Wisdom from the Grovedb team. So this goals for this sprint were worst case cost and checkpointing. We had a pleasant surprise regarding the timeline of checkpointing that Evgeny would talk about more. So the features. So last sprint we implemented or we changed the root tree from the dense Merkle tree to the AVL tree. And after doing this, we had to go back to path query merge to complete the second half of it because we're kind of blocked based on the root tree. So we finally completed the second part, and we did this by restricting the path to non-sub paths. So basically non-overlapping paths, just different paths, path queries, and then you can merge it. We also wrote a path query doc that describes and breaks down how the path query works and how the path query merge work. This is under the develop branch of Grovedb at the README. Then another feature I worked on was we are working on is the worst case cost. So now basically this is going to get the worst case values for every operation in Grovedb, from storage to merk to finally bubbling up to Grovedb. So this is still in progress. It's quite difficult because we have to understand every part of the code and what the worst case can be. So this is going to continue next sprint. Moving on to beginning to talk about some checkpointing and chunking.
Thank you, Wisdom. Hey, I'm Evgeny from Grovedb, and yeah, checkpointing and chunking. These are parts of another feature we want to have in Grovedb, which is called replication, and it will allow one node in network to be set to a state of certain block height, taking this information from other peers and verifying on the fly. And checkpointing is required to have a Grovedb state of certain block height stored on a node alongside to current actual state, and preferably in a storage effective way. We did it using RuxDB capabilities, which we use as a backing storage. So it quite meets our requirements. And next is chunking. Chunking is a process of splitting Grovedb in pieces, suitable to be sent over network and taken from many other peers, and eventually to build a local copy of Grovedb, and also verifying them on the fly, so no gigabytes of malicious data will be sent. And checkpointed state is what we're trying to replicate with chunks, so we did both these features. And one is done and one is in progress. And on that note, I'm passing my mic to Sam. Yeah, muted.
Oh, I'm sorry, I was muted. Hello, guys. So I'd like to say a few things very quickly about checkpointing and chunking. First thing is that we kind of had estimated checkpointing to take, let's say 2-3 weeks, and Evgeny finished it in a day. So he needs a round of applause for that one.
Congrats.
Yeah, it was really quite impressive what he did. He found a way to do it that we just hadn't thought about, but was very efficient. He actually created a pull request up to the Rust RocksDB to enable checkpointing, because they hadn't thought about it either. So it was very great. And so, but I also want to kind of explain very quickly, like Evgeny explained like what chunking does and what checkpointing does, but he didn't really explain why we're doing this. And the reason why we're doing this is for quick sync of new master nodes coming into platform. There are two ways to really sync in Tenderdash. The first one is to replay all the blocks from the Genesis, and that takes a lot of time, especially that the block time in platform is extremely small, like 5-7 seconds, and replaying millions of blocks would just take forever to sync. The other way of syncing is basically taking your state, creating chunks of your state and passing them to the node that's currently trying to sync, and it's much faster, and it gets the chunks from multiple different nodes on the network, a little bit in a peer-to-peer style, and so it will just make bringing a new node online quite quick. So that's why we're doing this. Yeah, so the next one, query can return different type of qualified results. That's a different story. This was basically more needed. This was basically before, every single time you asked for something from the database, you get back the key and the value. So if you say, hey, give me back this range from here to here, you get all the key and the values from the range of your query. Now, if you're only asking for one item, it doesn't really make sense to get back the key, because if you say, hey, give me thing at ID 14, you just want that thing back. You don't need 14 and then the element that you're getting back. So this just allows you to say, okay, I don't care about getting the key back, and it's a little bit more efficient. Now, we didn't do this story for the efficiency. It's more that for every item that we were querying, sometimes we actually needed the path back, and we needed the path back for another reason in fee distribution pools, because we needed to know basically the path of an epoch when you queried a specific advanced query. So we built this feature, and it can be used for more than it was needed for. Okay, let's go on to SDK. Oh, I think actually there might be a what's next. Yes. So what's next? We have efficient references. This basically just whenever we refer in the secondary indexes from one item, from the index to the actual item, we're doing it with an absolute path. The efficient references is basically using relative paths or even like little tricks to make it more efficient. And we do that just because every byte in our storage is worth something. So we try to heavily reduce the costs to make things, more efficient. The next one is we're also going to continue on the worst case costs and the continuation on chunking. But basically, when we're done with these items, we really only have one more item in Grovedb, which is tree references, and that's not a big thing. So we're pretty much nearing the completion for Grovedb for mainnet. So that's cool. We'll be the first team to finish the requirements. So somebody else can jump in front. Tenderdash team, I'm looking at you guys. You have a shot. Anyways, let's move on to SDK then.
All right. Thank you very much. As we had the team, Igor, in this sprint, just a little bit talk about the plans, which are basically the same as before, that we're going to continue with the chain synchronization process and the documentation update. All right. And we are going to have a team in this sprint starting tomorrow. Let's jump into the protocol. Ivan?
Yeah, so this sprint, we continued to preparing and releasing V23. We probably about the Devnet, we will talk a little bit later. But at this point, there are two main things this needs to be done for 23. It's fee calculation and fee pools. Yeah, so it is about the fee pools. We finally accomplished implementation today. And it took pretty long time because we introduced additional layer to the RS drive. We call it execution this moment, and it contains its mimic ABCI application logic, what we have already in JS drive. So it's kind of a bridge, ABCI bridge between Rust and JavaScript version. So now we can trigger some logic based on the current ABCI execution process in Drive, which simplifies basically the future development and which allow us to process the fees and distribute them into pools. I guess Sam, you will talk more about how it works, right, during the demo. So I would just say that only regarding the pools, only JavaScript part is missed, but it's actually done, and I think we will update it with new RS drive version tomorrow, and be good with pools.
So with that, I'll do the demo, right?
Yeah,
Please.
Sam has a demo to show how pools working.
Yes. So let me share a little terminal. Once again, this is not the most pretty demo, but it will give a good idea of how things work. Can people see the text?
Yep.
Well enough? Yeah. Okay, so basically, I've been using this Explorer demo, RS Drive Explorer, as kind of like a way to show off features. And before, I've basically shown contracts, like fees for contracts. Over the weekend, though, I built in blockchain simulation of blockchain execution, so you could kind of show the pools working. So like if we go here and we go like into blockchain, we have the following options for execution. We can view info, we can add master nodes, we can view our master nodes, we can execute blocks, we can list epochs, we can enter the epoch information screen, we can do strategies, and we can load our last strategy. Not all of these are working yet. The some at the end are not, but the ones that are working are good enough for the demo. So we're going to add 10, okay, let's add 10 masternode identities. So it's A10. And basically now we have 10 masternode identities, just so people know it's not a fluke. We can add another 5. So we have 15 masternode identities right now in the system. And we can actually view them by going VM. And right now, yeah, you have these 15 identities and their balance is 0 because basically we haven't executed any blocks. We haven't done anything really. So we can first actually just execute some blocks. Now, I do want to tell people that I've only ran this 2 times so far. So I finished a little bit earlier today. So if there is an issue, give me some. Okay, so basically there's 10 blocks are executed now, and our chain tip is block 11. So basically what happened is we did the ABCI simulation of 10 blocks, but there's nothing being done right now. There are no contracts being inserted. There's nothing that's actually happening in these blocks. So if we actually like check the master nodes, we're going to see that they still have 0 balance because literally no state transitions happened on the network. So what we're going to do is we're going to create a strategy by going into the strategy tab. And right here, we can view all of our current strategies, and there are no available strategies right now. So we have to create some. I erased them right before the demo. So what we're going to do is we're going to create a new strategy. And we're going to call it test. Why not? So we have a new strategy test, and we're going to add some operations to the strategy. So let's see what contracts we have available here. I think I only have the Dash Pay contract, but let's see. Yeah, we have the Dash Pay contract. So I know how the Dash Pay contract works in my head. Dash Pay contract has a profile, has a contact request. So what we're just going to do is we're going to add, in our strategy, we're going to create some operations for the Dash Pay contract. So we'll put in add op Dash Pay for the profile. And it basically, we're going to say that we want on average, not on average, every single time that it inserts this document in a block, we want to do it between, I don't know, 1 and 11 times. And then we want our chance that that we insert this event, 75%. So hopefully this will work. I don't think that actually worked. Sorry, guys. Oh, because I wrote app op instead of add op. Sorry, guys. That's why it didn't work. There we go. Oh, there we go. Add operation to strategy test. We're going to save the strategy. And we save the strategy test. And now we're going to exit the strategy screen. And then the strategy is currently loaded. So now if we execute things, it's going to automatically create these documents and put them into the state. So we'll do that, and we will execute blocks. So we can execute, I don't know, 50 blocks. Executed 50 blocks. Chain tip is now 60. And if we want, we can look at the info. And our current block, well, for some reason it says 59. There must be a bug there. We're still on epoch 1. No, we're on epoch 1 now. Before we were on epoch 0. And we can see the epoch storage fees to distribute are this. And our epoch processing fees to distribute are this. So literally we can just like add, can execute some more, I don't know, 10 more blocks, see what, and now if we do, we ask for the information again, we can see that the aggregate storage fees to be distributed and the processing fees have gone up from before. The reason why the storage fees to distribute have not gone up is because we're actually still on the same epoch. So basically the way it works is the aggregate, as state transitions come in, they get added to the aggregate storage fees for that epoch. And then at the end of the epoch, then they get distributed to the next 1,000 epochs. It's kind of a complicated process. Sorry if I'm not explaining it that well, but if we add, if we execute some more, let's say like we switch to the next epoch, which should happen 30 blocks from now. Let's try. We should get, yeah. So as you can see, the epoch storage fees to distribute has actually changed now. And if we want, we can just basically look at our current master nodes, view master nodes, and they should all have a balance because they should have been paid. Let's check. They all have been paid. This is the balance of all the master nodes in the system. So this is obviously a simulation, but it's a simulation just because I want it running on my computer. This is using DPP, this is using Drive, this is using all the logic except Tenderdash for consensus. But basically, as you can see, the system is working. As you can see, master nodes got rewards. The fact that a master node is being proposes a block in my simulation is completely random. And that's why we see some identities with a very high reward when some have a very low reward. In the actual way Tenderdash works, it's not random, it's pseudo-random. It's just like an order, like one after the other. So the balance would actually be a lot more equal, like between identities. So, I mean, I can show like if we add more identities now, if we add like another 3, right? And then we did, we wanted to view them, we'd see the last 3, you know, they don't have a balance because they just were added. But now if we wanted to execute, I don't know, let's say 100 blocks for this strategy, we just executed 100, and now we can see that the last 3 have a balance, and the balance is smaller because they came in later. So I hope people enjoyed this demo. I certainly am really happy because we just completed a big item that we've been working on for a very long time, and I'm very happy to show it working. Yeah, so.
There is a quick question that is the balance in DOFs.
No, the balance is actually currently in credits. So that would be 1 credit, 1,000 credits is 1 DOF. Yes.
Thank you.
The fees represented here, I also want to say, are not the total fees. They're currently just the storage distribution fees and the processing fees, but they're not adding in the validation fees, since the validation fees happen on a different layer and they aren't included in, well, I didn't include them. They're much, generally the processing fees and the storage fees are the highest and the validation fees are slightly lower. So, you know, I just didn't add it. Okay, so
can you stop sharing? So yeah, thank you. And
Yeah, thank you, Sam. So as already told, we released on the Devnet our recent 23 branch. It doesn't contain pools and fee calculation yet. That's what we're gonna do next sprint, since tomorrow. But at this point, everything what included 23 is working on Devnet and all tests are passing. So having core 18 working more or less stable, we can proceed. Now we're having pools, so we're gonna iteratively include the pools to our deployment and continue testing. Yeah, so this testing on Devnet on we're gonna continue next sprint. Also, we started to work on withdrawal transitions this sprint. It basically withdrawals. We already discussed it a few times, but just really quick remind you what is it. So since you can log your Dash to mint credits on platform, and master nodes gonna get rewards, and also we're planning more economic based on the credits in the future. It's pretty obvious that we need to convert credits back to Dash. So that's actually what we call withdrawal. And it contains two parts for MVP. It's like implementing the transition in DPP library. So the state transition for withdrawal. And the second part is signing. If you're talking about the scope of the protocol team. So this is the first part. It's in progress at this moment, and we're implementing it already in Rust DPP version, not in JS DPP. Anton will bring more rationale behind it later. Kostya, would you help me to explain ABCI++ and putting identities,
yeah, sure.
please?
So ABCI stands for ABCI blockchain interface, and this is the interface between Tenderdash and Drive that we use. And ABCI++ is the further improvement of ABCI protocol, let's say, which is used by the latest Tenderdash and Tenderdash as well. So we moved from ABCI to ABCI++ in JS Drive to support the latest Tenderdash. Yeah, this is what we've done at the moment. And masternode voting identities. So as you know, we have masternode identities. For instance, we have operator identity to split rewards between owner and operator. Yeah, and now we implemented voting identities for to use it for voting purposes. Yeah, so if masternode owner is using a separate key for voting, we create an additional voting identity in that case. Yes.
Yeah, thank you. I would just add that we already mentioned many times this term ABCI. ABCI is the application blockchain interface. So it's actually the protocol between our consensus library, Tenderdash, and actually the blockchain runtime, this Drive. And that's how the consensus library calls specific parts of Dash platform business logic. Yeah. So what's next? since we finished the spools, the only part what required for what we planned for version 23 is fee calculation. Be close to accomplish worst case calculations Grovedb, and having it, we can update Drive to utilize this new functionality. And we're going to continue to work on the releasing platform 23, testing on Devnet, and continue to work on withdrawal transition and withdrawals in overall. Yeah. Thank you.
Thank you, Anton.
Yep. Hi guys, Anton's here, and I'll give you today a little update on our Rust port effort. And I'll start with the thing we always start this update. That's our progress on the DPP side, and this represents the amount of closed tasks on the side of the DPP being the Dash platform protocol library. Can we go to the next slide? It's going to be a little bit more interesting this way, because I think the graph we've shown on the previous slide will be slightly less relevant in the coming sprints, since we are going to work on integrating our Rust DPP port into the bigger platform, Dash platform. And so here's, I'm going to talk a little bit about our plan going forward, what we are going to do with this port and what we are doing with it already, in fact. So we have 4 main areas of what we need to do with this port now. We have a component that's called RS Drive, and this is the first component we are integrating DPP into. That is because this is a new component that was started to be written in Rust. It's not a port of any other existing JavaScript component, so it needed pure Rust JavaScript implementation, since we don't have, since we can't really use JS library in it. And this, we actually started working on this previous week, and I've touched this a little bit, but since then we've actually finished the implementation. We in fact merged the pull requests today, and now on the platform, on the backend, we actually have our first component utilizing DPP now, which is RS Drive. Now we have 3 more major areas to work on. This is bringing all the changes from v23 into the Rust DPP port. Why this is a separate task and what's it doing here? The thing is, when we started to work on this port, the actual version, like the current version of the platform back then was v22. So we based the port on v22. Between v22 and v23, there were quite a number of changes to the platform protocol, and we need to backport them to the Rust DPP before we can switch the rest of the project to Rust DPP. Then what we're going to do, the functionality of Rust DPP that is used by RS Drive is somewhat limited. It's not to 100%, and we need to actually test all the methods, all the structures that we have in DPP to be sure that protocol works as intended. And for that, we go into create a WASM binding for the Rust DPP and slowly replace it in the tests of the current JavaScript DPP. And we're going to polish it until all the current tests for v23 JS DPP are passing using WASM binding of Rust DPP. And then we're going to go to a last phase, and that's integrating the newly made Rust DPP into SDK drive, DAPI, and test suite. This is the rest of the platform stack. And that's gonna take a while. And so this, what I was saying before, it's literally in the order we're gonna work on this. And we are going to start working on V23 changes this next sprint that we're going to start tomorrow. We have two separate things going on. First is, as you might have seen, the progress on the porting V22 features is not 100%. So we're going to work in parallel a little bit for porting V23 and finishing some of unfinished V22 stuff that's currently in progress. So all the V22 things are either done or in progress right now. There is nothing left that's untouched yet on this side. So we're going to work on V23. And this is going to take a while. And on the next reviews, I will actually dive a little bit deeper into what changes V23 exactly brings to the DPP. And I'll give more detailed updates instead of just the chart showing the progress. I will give more detailed updates on what we worked on and how this brings us closer to user release. That's it. Thank you very much, guys.
Thank you very much, Anton.
I would like to add one thing really quickly.
Please.
The demo that I did today was using Rust DPP. Would like to point that out, just so people do know that it is integrated.
All right, thank you very much. You already started answering the questions in the chat, but I'm going to read it out loud in case you want to answer it verbally here as well. So I guess the first question was send Mike, how checkpointing basically works. Is it about merging block hashes into chunk hash and storing it locally? Ivan, you answer this. Do you want to add something or?
Yeah, sure. So Grovedb on low level stores the data as key values in RocksDB, and checkpoints works on the low level. So it's a feature of RocksDB, and basically checkpointing, it's like when you do checkpoint, you create a snapshot of your database, and it doesn't copy files. It creates the hard links between SST tables in RocksDB. So it's more like a div, I would say. And it works on the key value database level, not on blocks level. I hope I answered the question.
All right, thank you. Also from San Mike, sorry, I missed the part with the strategy explanation. Could you explain what this entity about? Sam?
Yeah, I'm guessing you mean about my demo. So basically, when we think of executing a block, it has tons of state transitions inside of it. And because we're not, for a demo, I'm not going to type in, oh, I'd like to add this state transition, create this document, create this document, create this document. It would take forever. I thought of like, how could we mimic real world usage? So you can basically create a strategy and say like, okay, your strategy has, for every block, you insert 5 DashPay documents, DashPay profile documents, 17 contact requests, for every other block, randomly do this. And, basically it's just a strategy to mimic real usage. One strategy could be insert one thing per block. One other strategy could be insert 1 million things per block, right? And then you basically can save your strategies and then run them at any point in the future. So that's the point of strategies. I hope that answers the question.
Thank you very much. So the next question is about having to live stream at the same time.
Not a real question.
Yeah, all right. Platform V23 Lirius is going to master V23 platform.
It will.
Going to, yeah.
It will. So feature-wise, only one thing left is the fee calculation. So that's what we're gonna work in next sprint. That's only one feature, and then when we see core stable on testnet, then we release 23, merge it to master stable version, and release and then deploy to testnet.
All right. Thank you very much, Ivan. The next question is: will there be a library with examples of using the SDK?
I guess on Dash platform readme.io, there are examples how to use SDK.
There's also we had somebody recently join in documentation. He's actually making tutorials around this. So those are basically tutorials or kind of examples. Right.
Thank you very much. The second question is, DCG have a plan to create an algorithmic stablecoin?
I'll answer that one.
Please.
I don't know how to not swear here, but no.
So the answer is no. Thank you very much.
Definitive no.
It's
if somebody in our community,
I was just about to say that it's worth elaborating. Why is that? Because I think that's also an important point.
Well, DCG should not have any stablecoin, but if somebody wants to build a stablecoin on top of platform, by all means, go ahead. I mean, there's nothing to stop you, basically. Probably not in the first version. There might be some things that you can't do, but you know, I'm sure that somebody eventually will be able to create a stable coin on top of platform. Makes sense that somebody would probably want to do it. But definitely would not be a DCG-led initiative.
All right. Anton, do you want to add anything to that?
No, I just wanted to say, I just wanted to mention that creating algorithms stablecoins is this kind of hot topic right now. And the reason behind this is that algorithmic stablecoins are kind of almost always doomed to follow the same path as Terra Luna did. That's kind of an inherent property of algorithmic stablecoins, that they will eventually kind of be depegged like that. I haven't seen any algorithm that would actually prevent that from happening. So it's a very hard problem to solve. That's not like gonna provide a lot of value right now. If there is a company, so I would applaud this to not to DCG, but rather to some companies that actually wants to work in that direction.
All right, thank you very much.
Yeah, we cannot do everything, right? So right now
and we shouldn't. Sometimes you shouldn't do things, right? Just because you can.
Yeah, I mean, we have specific vision of platform as a stack for building decentralized applications, and stable coins are not there. So.
Well, I mean, for helping people build decentralized applications. So if that person wants to build a stable coin, we're not going to like artificially restrict it, but we're definitely not going to do it anything ourselves for it.
Thank you for your explanation. So from another question from James Doe is, how much Dash per username?
So currently, the numbers that I have are about, it's too much. Because when you, I'm guessing you don't mean just username. You mean identity, username registration, and DashPay profile. So all of that combined, I believe is slightly over $1 at the moment. So we definitely want to get those costs down. We have a few ways that we could do that, and we're working on that.
All right, thank you very much. We have another question, but I don't know if it's a question. It's a question mark in the end, which is decentralized marketing hub? Question mark.
I don't know what that means. If anybody, well, I mean, maybe there's a 30-second delay, right? So
yeah, some delays, yeah, with the stream.
Can maybe wait for some update to the question.
Right, please, if you have any more question, feel free to raise it. We are about to finish the session if there are no more questions coming in. One more question. Dash proposal fees. Is there a final solution being worked on so we don't continue changing the fees from 5 to 1 more or less in the future?
I'm trying to understand the question. Is there a final solution being worked on so we don't continue changing the fees from 5 to 1 more or less in the future? Dash. Oh, you mean for proposals, for governance, he means. So, well, there are some ideas, but we haven't actually spent much time on them. To be honest, we've been working on other stuff. Some of the potential ideas are, yeah, a fee that adjusts to the value of Dash is well, inside of platform, all masternodes are represented by a voting identity. So when we have the voting identity, we can create contracts that masternodes can vote on quite easily, a lot easier than our current voting system. So some of the stuff that they could vote on is the current fee that they'd want to see. And it can be a constantly updating process, like, fees decided every 3 to 4 months, and people could be like, oh, I wanted 1 Dash, I wanted 10 Dash, I wanted 2 Dash, I wanted 0.5 Dash. And basically, if you take the middle of all the values that are voted on, generally you get something that is representative of the network, because the average, obviously, somebody voted for 10 million, it would be an outlier. So if you just took the middle number of every vote, generally you'll have what seems to be, 50% of people want, 50% of masternodes wanted one way on one way, 50% wanted higher on the other side. So that's kind of an idea that we've had, but it's not going to be out for some time.
All right. So we get to the end of the questions. Thank you very much for being here, for raising those questions, generating a conversation with us. If you have any feedback, any other feedback, let us know either in the chat or on Discord. Thanks for joining. See you in 2 weeks.